So the first few questions will give us a little bit more practice at predicting what is made at each electrode during electrolysis, especially if we're dealing with a solution. So the first question says, what would be produced at the anode and cathode if copper chloride solution is electrolyzed? And the solution is in bold to prompt us to remember we've got water in there as well as the copper chloride. So the first thing I would do is find a small blank piece of the exam paper somewhere, maybe the bottom of the page, and draw a quick sketch of an electrolysis cell. So I can now start putting on there the ions that we've got. So it's copper chloride, so I'm going to draw in some copper ions, Cu2+. The chloride will be Cl- because chlorine is group 7 and they all make 1- ions. But because we've got water, the water dissociates to produce hydrogen ions, H+, and also hydroxide ions, OH-. So now I can work out what moves towards the anode. We remember that opposite charges attract. So going towards the positive anode, we're going to have the chloride ions moving that way and the hydroxide ions moving that way. So the next thing we need to work out is what will be produced at that side. Will it be the chloride or something to do with the hydroxide? So we need to remember the rule for the anode where we've got a solution. And the rule is if we've got halide ions, in other words halogens, that will be discharged or made. If we haven't got halide or halogens, then oxygen is made. Now in this case we can see we've got chloride ions, which is a halide ion. So that's the one that actually turns into something. So at this side, in this inverted test tube, we would have chlorine gas being made. Chlorine. Now if we consider what moves towards the cathode, the copper ions will move towards the cathode and the hydrogen ions will also move towards the cathode. And we have to remember the rule for this side, and in this case the rule is the least reactive is made or discharged. And in this case, copper is less reactive than hydrogen. So it's copper that is going to be made at this side. So what we would notice is we would get copper building up on the electrode just here. So copper is made at this side. So the two things we've got being made are copper and chlorine. Question 1b, this is just for higher tier students. Write the half equation for the reaction at each electrode. And we need to remember with electrolysis, ions turn into atoms. So let's start off with copper. We've got copper ions, Cu2+, changing into copper atoms. Okay, so let's just move the arrow over a little bit to give us some more room when we're doing this. So because we've got a 2+, we're going to need 2 electrons, and the electrons in this case go on the left. Now we can check if we put the electrons on the correct side. We add up the charge on the left, which is 2+ and 2- equals 0, and we've got no charge on the right hand side. Now the half equation for chlorine being produced, again we've got chloride ions changing into chlorine atoms. This time the electron is going to go on the right hand side, and it still balances because we've got a 1- charge on the left and a 1- charge on the right. But we have to remember that the halogens go round in pairs. They form diatomic molecules. So if we're going to end up with Cl2, then we need to have 2 chloride ions to start with, and that will produce 2 electrons. So that is correct. Okay, let's look at another example. What would be produced at the anode and cathode if aqueous sodium sulfate is electrolyzed? So I've just reworded the question slightly on this one to show you that if it says aqueous, we're still talking about a solution. So it's sodium sulfate in with water. So once again, we do a quick sketch of an electrolysis cell. And now we can start writing the ions on so we know what ions we're dealing with. So sodium sulfate. Sodium is in group 1, that's Na+, they all form 1+ ions. Sulfate, we just need to remember, is SO4 2-. And once again, we've got the water dissociating to make hydrogen ions and OH- ions. So the anode is going to attract the sulfate and also the hydroxide ions. So once again, we need to remember the rule. If the halide ion is present, that is discharged. If not, oxygen is made. Now in this case, we haven't got a halogen or a halide. We've got sulfate. We haven't got chloride, bromide or iodide. No group 7. So in this case, it will be oxygen that collects at the top of here. So when the electrolysis cell is switched on and running, we'd see bubbles of oxygen going up towards the top of that measuring cylinder or test tube where it will be collecting. Now the cathode will attract the positive ions. So we need to decide, will it be sodium or hydrogen that's made? And the rule for this side is it's the least reactive that is made. Sodium's near the top of the reactivity series as it's an alkali metal. So hydrogen is definitely less reactive. So in this case, it's hydrogen that would bubble up to the top of that test tube. So the two substances produced in this case are oxygen and hydrogen. So once again, we'll try and write the half equations for each electrode. We'll start with the hydrogen. Hydrogen ions turn into hydrogen atoms. So the electron needs to go on the left for it to be balanced. So we've got 1+ and 1-. 0 charge, that is on the left hand side, 0 charge on the right hand side. But hydrogen also goes round in pairs. It's a diatomic molecule. So that means we need to start with 2 hydrogen ions and also 2 electrons. Now the oxygen is actually produced from the OH- ions, and this is probably just an equation that you're going to have to learn because it will be very difficult to just work it out. So if we start with 4 hydroxide ions, they change into 2 water molecules and 1 oxygen molecule and 4 electrons. So we've got 4- charge on the left and 4- charge on the right hand side. So here's a question where it could ask you to describe a method for 6 marks. Describe how you could investigate how the time the electrolysis cell is switched on for affects the volume of the gas collected at each electrode when electrolysing sodium chloride. So pause the video, have a go at writing an answer, and then resume the video to see if you've missed anything out. Okay, so this is what we should be putting. First of all, fill the electrolysis cell with the sodium chloride solution. That could also be called the electrolyte because it's a solution containing ions. Secondly, we also filled 2 graduated test tubes. Now, graduated test tubes are test tubes with measurements at the side. Or you could use small measuring cylinders, and we put in the same solution into those 2 items. We then use cling film to be able to turn the test tubes or the measuring cylinders, whichever we're using, upside down and place it over each electrode, ready to collect any gas that's made. Then we would connect it to the DC power supply and set it to 6 volts. And we'd switch it on and leave it for 2 minutes. We'd then measure how much gas is made in each measuring cylinder at each electrode after the 2 minutes. And then we would repeat the whole process 4 more times. But instead of doing it for 2 minutes, we'd leave it for 4 minutes, 6, 8, 10 minutes, and so on. So for this investigation, we want to know what is the independent variable, what is the dependent variable, what are the control variables, and explain how you would make the investigation safe. So pause the video, have a go at these answers, and then resume the video to see how you got on. So first of all, the independent variable, what we've changed is the time that the electrolysis runs for. The dependent variable, the thing that we've measured, will be the volume of gas produced at each electrode, and we'll try and use the word volume rather than amount. The control variables that we're keeping the same for a fair test will be the voltage on the power pack, so keep that at 6 volts, and also the concentration of the electrolyte, in this case the sodium sulfate solution. Now, when we're talking about making the investigation safe, we need to remember that we're producing toxic chlorine gas. So we don't keep it on for more than 10 minutes in order to limit the amount made. We could also make sure we have windows open for ventilation and keep the voltage and current low as we put in electricity through a liquid. We know that large currents and voltages can be fatal if a large amount of electricity goes through a liquid. So we're making sure we keep that to 4 or 6 volts.